Okay, we're just going to look at the dot product first of all to find an angle. All right, so basically A dot B equals the magnitude of A, the magnitude of B, and then cos theta. That there is on your formula sheet. Now, to actually prove that, what we do is we just use a triangle. We put an angle between them. We call that A and we call that B. Now, I'll call that big A, big B, and O. So basically, if I wanted to get, if I use like the cosine rule, that means that the magnitude of AB squared will equal A squared in magnitude plus B squared in magnitude minus 2 times AB cos theta. Okay, now AB will equal B minus A. Because if you trace around this and you're doing AB is that way. So B minus A, if you start at A and you trace along A, that would be minus A because you go in the opposite direction, you go to B. So you go from the tail and you trace, it's in the opposite direction along to the head. Okay, so that means that we have B minus A all squared. We're trying to prove that's A squared plus B squared minus 2AB. I'm not trying to prove it is equal to this, cos theta. And that's just the cosine rule. Now, in order to do this part here, all that we need to do is do B minus A dot B minus A. And that's that rule. A modulus of A squared is A dot A. And I'll prove that later in our thing because it's on our list. Okay, so when you expand this, you use the distributive law. But you use B dot B minus, now that's going to be 2 lots of B dot A. Okay, so instead of putting times, you put dot. So it's going to be that one. And then plus A dot A. Okay, now that equals the modulus of A squared plus the modulus of B squared minus 2 times mod A mod B. And then it says cos theta. Doesn't it? Just get rid of that so it's a little bit neater. So 2 mod A mod B cos theta. So B dot B is equal to mod B squared, 2B dot A, and this is mod A squared, equals mod A squared plus mod B squared minus, remember this is just 2AB cos theta. So the mod A will go out with the mod A, mod B squared will go out with the mod B. So you have minus 2B dot A equals minus 2 mod A mod B cos theta. The minus 2's will cancel out and you have B dot A equals mod A mod B cos theta. So B dot A is the same as A dot B, mod A mod B cos theta. And yeah, that's basically the rule. Okay, so once you've figured out that rule to get the angle, we'll just rewrite it here. So A dot B equals mod A mod B cos theta. Then what you can do is you can solve for cos theta. And that this expression, by the way, this one here is on your formula sheet. It's A dot B on A mod B. And you can use that actually to find an angle. So we're just going to look at an example to find an angle between two vectors. So find the angle between A, which equals 2i minus 3j, and B, which equals minus 4 minus 2. Okay, so the rule states A dot B equals mod A mod B cos theta. You've got to solve for cos theta. So cos theta is A dot B over mod A mod B. So that means A dot B. So you multiply the x's. So that's 2 times minus 4. And then you multiply the y's. So that's minus 3 and minus 2. Minus 3 plus times minus 2. Okay, and that is all over mod A. Mod A is the square root of 2 squared plus minus 3 squared. And mod B, minus 4 squared plus minus 2 squared. Okay, this minus 8 plus 6 over the square root of 4 plus 9 times the square root of 16 plus 4. So it's minus 2 on root 13 times root 20. Okay, so to get theta, we just go shift cos the minus 1, minus 2 on root 13 times root 20. You just got to chuck that in your calculator. Now notice that it is a negative angle. You don't really need the negative there. If you put the negative there, you're just going to get the obtuse angle. So when two vectors meet, it could either be acute or obtuse. Okay, so I'm quite happy for you just to get the acute angle. Not wrong if you do get the obtuse. And you end up with 83 degrees to the nearest degree, and that's your angle. Okay, so what I'd like to look at now is basically if two vectors are perpendicular, then their dot product would be 0. So I want to show you why and just look at a couple of examples to do with that. So if A dot B equals mod A mod B cos theta, then if you have two vectors that are perpendicular, then theta must be 90 because that's the angle between the two vectors. So if you sub 90 in there, then A dot B equals mod A mod B cos 90. Now cos 90 is 0. That's mod A mod B cos of 90 would be 0. So that means that this whole thing here will end up being 0 and the dot product would be 0. So for example, just to prove 2i plus 4j and minus 6i plus 12j, prove that they are perpendicular. Perpendicular. Wait a minute, let's get that right. Prove that they are, and we'll just do the symbol perpendicular. Okay, so A dot B, so you multiply the x's and add them together, and then you multiply the y values and add them together without the j's and the i's in it, because you're just meeting x1 times x2 plus 4 times. Now this one, we can see they're actually not perpendicular, because that's minus 12 plus 48, which is 36. So that one is not perpendicular. Sorry about that. So let's just look for one that potentially might be. So let's prove that this one is perpendicular to minus 6i plus 3j. Okay, so the dot product for that one would be 2 times minus 6 plus 4 times 3 minus 12 plus 12, which equals 0. Therefore, A is perpendicular to B. Okay, and just a different type of example. Okay, let's just say if A3 and 4 minus 2 are perpendicular, then I want you to find A. Okay, so if you use the perpendicular vector rule, A dot B equals mod A mod B. And that's a different A to this. I probably should have used a different unknown. I think I might just quickly change it just so it doesn't confuse anybody. Yeah, let's make that an M. And what we're going to do is we're going to find M. Okay. All right, so let's have a go at this. So we have A, which is M times 4, because you do the x value of the first one times the x value of the second one, and then you add the x value, the y value times the y value. So M times 4 plus 3 times minus 2, and the dot product has to be 0 because it's cos of 90, and cos of 90 is 0. So this would be 0. So 4m minus 6 is 0. So 4m equals 6, and m is 6 over 4, or 3 on 2. So for these two vectors to be perpendicular, the m value would have to be equal to 3 on 2. Okay. So let's just look at another one just in case. So it's the third example. So show that 2, 5 and minus 10, 4 are perpendicular. Okay. So A dot B will equal 2 times minus 10. So times the x's and 5 times 4. Minus 20 plus 20, which equals 0. Therefore, A is perpendicular to B. And just one where we find the unknown. 5mi minus 2j and 3i plus 5j. Find m if the two vectors, I'll call this A and this is B, if A and B are perpendicular. Okay, so let's go for it. So A dot B would be 5 times 3, because you just multiply the x's, and then you've got to add on the y. So minus 2 times 5. So minus 2 times 5. So A dot B, this would have to equal 0. Now that's actually 5m. 5m times 3 minus 2 times 5 is 0. So 5m times 3 minus 2 times 5 is 0. 15m minus 10 is 0. 15m equals 10. Divide by 15, 10 on 15, which equals 2 on 3. And that's it.